Hello guys. So in this video we are going to cover our week 3 of IIT Madras Machine Learning Foundation. So week 3 of MLF. Okay. So in week 3 the first topic is column space. So column space is denoted by a span of A1, A2 and up to AM. So if I take an example of column space, suppose you have a matrix A 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so you want to find the column space of this matrix. The first step is convert this matrix into REF form. Okay, so the REF form is 1, 2, 3, 0, minus 3, minus 6, 0, 0, 0. Okay, so we can see that the rank of a matrix is 2. How can we find the rank? The rank is the number of non-zero rows. Okay, so if the rank is 2, then the dimension of column space of A will also be 2. Okay, now as you know, we have to find the identity element. So the first non-zero element of the row is the identity element. So you have to check only one thing, which column contains the identity element will be the column space of matrix A. So as we can see, the first and the second column contains the identity element. So the basis of the column space will be 1, 4, 7, comma 2, 5, 8. That is column 1 and column 2. So this is the column space of this matrix A. If we take another example, let's say you have a matrix 1, 2, 3, 0, 1, 4, 0, 0, 1. As you can see, this matrix is already in the REF form. REF is row echelon form. So all three rows contains the identity element. So the column space of A will be 1, 0, 0, 2, 1, 0 and 3, 4, 1. Okay, I hope the column space is clear. Second topic is null space. So we have to find the null space. The general equation of null space is Ax is equal to 0. Okay, so this also we can understand by an example. Suppose you have a matrix as 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now the area form of this matrix is 1, 2, 3, 0, 1, 2 and 0, 0, 0. Okay, now this is the REF form. Now you have to multiply this REF form into x and equate it to 0. So the REF form is 1, 2, 3, 0, 1, 2 and 0, 0, 0. Now x1, x2, x3. Then equate it to 0. Okay. Though now you have to find the dependent and independent variables. So the column which contains the identity element is in dependent variable, and the column which do not contain the identity element is independent variable. So we can see column 1 and column 2 are dependent variable, whereas column 3 is independent variable. Okay, so now you will get two equations, x1 plus 2x2 plus 3x3 is equal to 0 and x2 plus 2x3 is equal to 0. Okay, now for writing the null space, you have to keep one thing in mind, that the null space will be in terms of independent variables. Okay, so here we can see column 3. Column 3 is as same as x3. So x3 is independent variable. Okay, so now I can write x2 as minus 2 times x3. Now if I put this in equation 1, so x1 plus 2 times x2 is minus 2 times x3. So minus 2 times x3 plus 3x3 is equal to 0, and then x1 minus 4x3 plus 3x3 is equal to 0. x1 minus x3 is equal to 0, so x1 is equal to x3. Okay, now I got two relations. So first as x1 is equal to x3 and x2 is minus 2 times x3. So for writing null space of a matrix A, the null space will be x1, x2, x3. But as I have told you that null space will be in terms of independent variables. So in place of x1, I have to write x3. In place of x2, I have to write minus 2x3. And in place of x3, we will write x3 only. If I take x3 common, so the null space will be 1, minus 2 and 1. So this will be your null space. So this is the method of finding the null space. First of all, you have to convert the matrix into REF form, then find which of the variables are dependent and independent, then multiply it with respect to x and equate it to 0. You will get several equations. After solving your equations, you have to keep one thing in mind, that for writing null space, every element should be in terms of independent variables. Okay, so this is your null space. And talking about rank nullity theorem, rank of A plus nullity of A is equal to number of columns. Suppose we have, like, if we take an example, this matrix, rank of this matrix is 2. Okay, so if the rank is 2, then 2 plus what is nullity? Nullity we have to find nullity, and number of columns. What are, how many columns of this matrix? There it has 3 columns. So 2 plus nullity of A is equal to 3. Then nullity of A is 3 minus 2, that is 1. So this is rank nullity theorem. Okay, I hope it is clear. Third topic is row space. So row space is nothing, it is as same as column space. Suppose you have an example of, again same, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then the first step is to convert it to REF form. So the REF form is 1, 2, 3, 0, minus 3, minus 6, or 0, 0, 0. Okay, so now the row space will be the number of non-zero rows, that is 1, 2, 3 and 0, minus 3, minus 6. So this is your row space. You just have to see how many are the what we can say, non-zero rows. Okay, next topic is left null space. Left null space, like, what was null space? Null space was Ax is equal to 0. Okay, now left null space is A transpose Y is equal to 0. Okay, so if we take an example, A is 1, 2, 3, 4, 5, 6. What is the dimension of this matrix? There are 3 rows and 2 columns, so 3 cross 2. Okay, let's take a transpose of this matrix. Those who don't know what is transpose, just write columns as rows and rows as columns. So 1, 2, 3, 4, 5, 6. Okay, and what is the dimension? It is 2 cross 3. Now, what was the equation of the left null space? A transpose Y should be equal to 0. Now what is A transpose? A transpose is 1, 3, 5, 2, 4, 6, and then multiply it with y1 comma y2 is equal to 0. Okay, so this is left null space. You will get two equations. Okay, you can perform the REF here. Okay, so if I perform REF, if I convert A transpose into AREF, that is 1, 3, 5, we can do the operation as R2 is R2 minus 2 times R1. Okay, so 2 minus 2 is 0. 4 minus 6 is minus 2. 6 minus 10 is minus 4. Then y1, y2 is equal to 0. Okay, and if I divide the second row, divide by minus 2. So 1, 3, 5, 0, 1, 2. Yeah, 0, 1, 2. And then y1, y2. As I have told you, we have to find the dependent and independent variables. So those columns contain the identity element will be dependent variable, and those who do not contain the identity element will be independent variable. So in this case, column 1 and column 2 are independent or dependent variable. Okay. So we'll get two equations, right? So y1 plus 3y2 plus 5y3 is equal to 0, and then y1 plus, sorry, okay, so this will be y1, y2, y3. Okay, sorry for the mistake. This will be y1, y2, y3. Okay, so we'll get two equations as y1 plus 3 times y2 plus 5 times y3 is equal to 0. Then y2 plus 2 times y3 is equal to 0. Okay. Now that independent variable is y3, so our subspaces will be in terms of independent variables. So y2 is equal to minus 2 times y3. Okay, this is the first relation. If I put this in equation 1, so y1 plus 3 times minus 2 y3 plus 5 y3 is equal to 0. Okay, then y1 minus 6 y3 plus 5 y3 is equal to 0. Then y1 minus y3 is equal to 0. So y1 is also equal to y3. Okay, this is relation 2. So for writing the left null space, this will be span of x1, x2, x3. So in place of x1, we will write a y3. In place of x2, minus 2 y3. In place of x3, we will write y3. Okay. So if I take y3 column, this will be same as 1, minus 2 and 1. So this is your left null space. I hope it is clear. The column space, null space, row space, and left null space. Okay. And column rank of column rank is dimension of column space is equal to row rank of dimension of row space. Now length of a vector. Length of a vector. I don't have to explain as much. Okay, let's take an example. If we have a vector x1, 2, and we want to find the length of this vector, then length of this vector would be denoted by mod. Okay, yeah, so mod will be under root of 1 square plus 2 square, that is under root 1 plus 4, that is under root 5. So root 5 is the length of this vector. Okay, next topic is orthogonal vector. Okay, orthogonal vector I have already taught in lecture 2. That is, the dot product should be equal to 0, and in this course we are considering x transpose y is equal to 0 and also equal to y transpose x. So the orthogonal vectors, the dot product should be 0. And for orthonormal vector, what is the condition for orthonormal vector? The dot product should be 0 and the norm of the vectors should be equal to 1. Okay, norm or we can say length. Norm is nothing but length. Norm or length. Okay, so this is also clear. Now comes projection. Projection of a matrix, you can say creating a shadow of one vector onto the other vector. So if I want to say find the projection of vector A on vector B. Okay. Suppose we have two vectors. Let's take this. Okay. So this is A vector and this is B vector. You want to find the shadow of this vector on A vector. So how you will write? You will write projection of A vector on B vector is inner space of A transpose B divided by B transpose B into B vector. Okay. So this is how you find the projection of one vector on another vector. If we want to do the reverse, if we want to find the projection of vector B on vector A, okay, so nothing, projection of B vector on A vector, this will be B transpose A divided by A transpose A into A vector. Okay, this is a formula of finding projection of one vector on projection on another vector. Okay, now comes projection matrix. Projection matrix. What is projection matrix? Suppose they ask you to find the projection matrix of A vector. How you will find the projection matrix of A vector? The formula is A into A transpose, inner product of A into A transpose divided by inner product of A transpose into A. Okay, so this is a formula for finding the projection matrix of A. If I take an example, okay, so we have a vector A is equal to -1, 3, -2 and 1. We want to find the projection matrix of A vector. So what is the formula of projection matrix? Inner product of A into A transpose divided by inner product of A transpose into A. Okay. What is the dimension of this vector? Dimension is row into column. There are how many rows? 4 rows into 1 column. Okay. So what is A transpose? A transpose will be -1, 3, -2 and 1. Okay. So what we have to do, inner product of hmm, inner product of A into A transpose divided by A into A transpose. A transpose into A, sorry. A transpose into A. This is your procedure of finding the projection matrix. So, okay. So what is the dimension of this now? Row into column, 1 into 4 and 4 into 1. So this will give a proper value. So the value is 15. You can say -1 into -1, 1 plus 3 into 3, 9, 9 plus 1, 10. minus 2 into minus 2, 4, 10 plus 4, 14, 14, 1 into 1, and 15. So 1 by 15, and multiplication of the matrices will be 1 minus 3, 2, 1, minus 3, minus 6, 3, 2, minus 6, 4, minus 2, minus 1, 3, minus 2, 1. Okay, so this is your projection matrix. I hope it is clear. Length least square approximation. Least square approximation. Okay, so we know that the general equation of find solving equations are ax is equal to b. We are considering as ax is slide maybe equal to b. So we can say that A transpose A into X is equal to A transpose B. So X is A transpose A inverse A transpose B. So this is a formula for finding the least square approximation. Okay. So if I take an example, y is equal to mx plus b. Okay. This is the general equation of a line, and we have given a point 1 comma 2, 2 comma 3, and 3 comma 5, and we need to find the least square approximation. How you will find the least square approximation? Put the values of x comma y in the equations. Okay. Mhm. Yeah. First of all, you need to do one thing. You have to make a design matrix. What is design matrix? On the left hand side of the matrix, you have to write the values of x. So what are the values of x? 1, 2, 3. 1, 2, 3, and 1, 1, 1. This is your design matrix. Okay, this is your design matrix. Now x is equal to m and c. This is parameter vector. Okay, what is b? B is 2 comma 3 comma 5. Okay. Now, what was the equation? Equation was x is equal to A transpose A inverse A transpose B. Okay. So you have to find A transpose A. A transpose A. So the value of A transpose A is 14663. Okay. And what is the value of A transpose B? A transpose B is 2310. Okay. Either do this way, or you can simply say A transpose A into X is equal to A transpose B. So what is A transpose A? 14, 6, 6, 3. What is X? M, C. What is B? A transpose B? 23, 10. You will get two equations from these vectors. Okay. Or you can do one thing. You have like, you know how to find the inverse of a matrix. So, or you can simply say you will get 14m plus 6p is equal to 23. 6m plus 3c is equal to 10. Okay. Now you can solve this equation. You can multiply this equation with 2. So 14m plus 6p is equal to 23. 12, sorry, 12m plus 6p is equal to 20. Subtract both the equations. You will get 2m is equal to 3. 3. So what is the value of m? The value of m comes out to be 1.5. Okay. Now what is the value of m? M is 1.5. So 12 into 1.5. 1.5 you can say 15 by 10. Sorry, right in the main equation. 6 into 1.5 you can say 15 by 10 plus 3c is equal to 10. Okay. Now 3c is equal to 10 minus uh, you can say 2 by 10 to 15 by 10. Okay. So 3c is equal to 100 minus 15, 85, 85 by 10. Okay. And p is 85 by 30. So you can simply solve this. Let me calculate this. So this will be around 2.6. Okay. Now we have to find the least square. So the value of m, and we got the value of m and c. So y is equal to mx plus c is the main equation. So what is m? M is where m is 1.5. M plus c is 2.8. So we got the values of m and c. Oh, okay. Now this was to least square yeah, approximation. There's a general formula of finding the error. You will never face any numerical question, but it can come as a formula question. Like they will ask what is the correct formula for finding the total error. So this is the formula: 1/2 a theta minus y whole transpose into a theta minus y. And how will find theta? Theta is a transpose y divided by a transpose a. These are the things which you have to keep in your mind. Okay. So these are the topics uh, which are covered in week 3. So let's do some questions. Okay, so you can do the practice assignment and graded assignments on your portal. I will. Okay, so here is an example. Let's do one example. We got the vector v3, 3. Okay, we need to find the projection matrix of vector 3. So how you will find v into v transpose divided by v transpose into v. Okay, again 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. You can do the multiplication. So the final answer is 1 by 27, 999, 999. This is the projection matrix of a vector B. Okay. Okay. So there is a short trick of finding what? Least square approximation. And you have to keep one thing in mind. This short trick will work only when n is 1. N is what? Degree of equation. Degree of equation. What is degree of equation? Degree is highest power. Highest power. Okay. What is the short trick? Okay. So basically in least square approximation we have to find two things, m and c. So the first method of finding value of m is n times summation of x y minus summation of x summation of y divided by n times summation of x square minus summation of x whole square. How you will work? How this formula will work? You got the values of x, x1, y1, x2, y2, and x3, y3. So we have to find summation of x, summation of y, summation of x, y. Yeah. So and summation of x, y. Also. So what is summation of x? Uh, 1 plus 2 plus 3. That is 6. Summation of y, 2 plus 3, 5, 5 plus 5, 10. What is summation of x, y? 8. What summation of x square? You can do on your own notebook. Summation of x square will be 1 square plus 2 square plus 3 square. So 1 plus 4 plus 5, that is 14. Okay. And and after solving these values, then simply put the values of that expressions in this formula. And for finding the value of c is summation of y minus m times summation of x divided by m. After finding m, put the value in this equation. These are the two equations which will help you to find the least square approximation of and value of n 1. Okay. So this is the short trick of finding least square approximation only when the degree of the equation is 1. Okay. So that's all for week 3. I hope you all understand the concepts. If you do not understand anything, you can write in the comment sections, or you can do the practice assignment, activity questions, and graded assignments in the portal. Now, in the next video, we will cover week 4 topic. Then I will make some videos on the PYQs of week 1. Okay. So I hope this video is clear and you won't be having any problem while solving the practice assignment and graded assignment. Okay. So let's wind up this session. I hope you like it. In the next video, we'll cover week 4 topics. Okay. Bye bye. Take care.